So let's expand upon what an OR and AND statement means in math. So from the previous video, we know that an AND statement is true if both parts are true, and we know an OR statement is true if at least one part is true. I want to show you something cool about AND and OR. So we know an AND statement is true. AND is true if both parts are true, right? But an OR, and we know an OR, okay, let's do that. So we know an AND statement is true if both parts of the statement are true. And we know that an AND statement is false if at least one part is false. Now let's look at an OR statement. An OR statement, or OR, is false if both are false. OR is true if at least one is true. Now let's see if we can, let's compare them and see some kind of like, almost like mirror image aspect or some symmetry aspect with AND and OR. So we said that an AND is true if both are true, right? That's the only way an AND could be true. But at the same time, let's look at an OR statement. OR is false if both are false. So we see that what makes an AND true, for both of the parts to be true, is what makes an OR false is if both parts are false. So for an AND statement, if both are true, then the AND statement is true. If both are false for an OR statement, then the OR is false. So it's almost like you replace the AND and an OR and you switch true and false. So if you just switched the OR and you switched the falses, true to false, you get the OR statement. Because both have to be true, both have to be false. Then OR is false. Both have to be true, then AND is true. And similarly, you can look at the OR statement and AND statements at the bottom. An AND statement is false if at least one is false. But then for an OR statement is true if at least one is true. So you see there's kind of some symmetry here between the AND and the OR statements. I'm just going to do a few quick examples of AND and OR statements to hopefully hammer it in your head. What is the difference between an AND and an OR? Given examples, so you can make it concrete in your head. And if you need be, just quickly recap. If you didn't understand what I meant regarding the symmetry, go back and rewatch it a few times. Or if you understand it, then there's no need for that. Let's go quicker. Okay, let's do some quick examples. Okay, let's look over these AND examples. So remember, an AND statement is only true if both parts are true. So we have to show that both parts, so this part and this part is true for the AND statement to be true. So let's do that. Is 1 plus 1 equal to 2? It is. So this is true. And is 1 minus 1 equal to 0? That is true. So since 1 minus 1 is equals to 0 and 1 plus 1 is equals to 2, since both parts are true, that's what it means for an AND statement to be true. So the AND statement is true. Let's do the next part. Let's do the next example. So 1 plus 1 is equals to 2. That is true. And 1 minus 1 is equals to 1. That's not true. So since both parts are not true, this AND statement is not true. So before, the AND statement was true because both parts were true. And in this case, the AND statement is false because both parts are not true, right? So let's look at the last example. 1 plus 1 is equals to 0. That's not true. And I don't need to evaluate this part because an AND statement is true if only both parts are true. Since I've shown this part is not true, it's impossible for the and statement to be true. So if you can show that one part of an and statement is not true, you're done. So this is false. Now I'm just going to quickly change the ands, all these ands to ors, and do the same example to show you the difference between and or. Okay, let's do it again. Is 1 plus 1 equals to 2? That is true. Now, for an or statement, it's true if at least one is true. So I don't care what the other one is, because since I've shown one of them is true, the or statement is true. Let's do the next example. So 1 plus 1 is 2. Again, that is true. There's no point of showing if the other one is true or false, because the or statement only asks is one true. Even though for this one it is true and this one it's false. So this 1 plus 1 is 0, but 1 minus 1 is equals to 1. This doesn't matter. Because we've already shown that one part is true, at least, since we've shown at least one of them is true, the or statement is true. Let's do the last one. Is 1 plus 1 equal to 0? No. Now, this or statement could still be true if the second part is true, right? Because the or statement only asks for one to be true. Well, let's check. 1 minus 1 is not equals to 1. So 1 minus 1 is 0, but it says 1. So this is false. So since both parts are false, this or statement is false as well. So those are some quick examples showing you some symmetry aspects related to and or, as well as I just done some examples to like clarify what I mean, what an or statement and what an and statement means in math. And if you have any troubles, hopefully rewatch the video. If you have more questions, just post any replies in the comments below.